Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabuti Wasos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 10. It says A, B, and C are three events. The probabilities of these events or any combination of them occurring is given in the Venn diagram below. So as we can see our diagram there, then 10.1.1 says if it is given that the probability that at least one of the events will occur is 0.893, calculate the value of y, the probability that none of the events will occur. So as we can see, y here is outside of the event. So that means this is the probability that none of the events will occur. But now let's understand the statement. At least one of the events will occur. Now, when we see at least, this means it's that particular number or more, right? So at least one of the events can mean one event or more than one event, right? So obviously, if we have one or more than one event occurring, that means it can encompass all of these events occurring. So it can be one, can be two, or three. At maximum, we have three events. So that means all of the events can take place there. If they say at least one of the event will occur, right? So that means that this probability that we are given here is the probability that either A, B, or C can occur, right? So which is, if we use or, that means it's the union of all these events, right? But then remember, how are we going to get that none of the events will occur? This represents that all the events might occur, but then we want to get the probability that none of the events will occur. So that means we can tackle that using our knowledge of complementary events to say if we are looking for the probability of no event, this means let's have 1 minus the probability of at least one event, right? And then now this will become probability of no event is represented by y, and then this is 1 minus the probability of at least one event occurring is 0.893. And then our y is equals to 0.107, right? So there we go. If you are to follow the fact that we have to round off our answers to two decimal places, it becomes 0.11, right, as per the instruction. Okay, then cool. Now, let's go to B. So B says, let's now calculate X, the probability that all three events will occur. So now that we are given that when we add all of this A, B, C, we are going to get 0.893 because this represents the union of all events. That means in order to get X, it's just straightforward. So B, to get X, we're just going to say it's 0.893 minus everything that we are seeing here. So minus the 0.05. So we're just going to put it inside the brackets, all of them. Then you make sure that you put every number that you are seeing there. Then plus 0.2, and then plus 0.183, right? Then X is equals to 0.893 minus, if we add all of that together, gives us 0.733, which your X now will become 0.16. So it was only 1 mark. That means you can even do it with your calculator and just write the answer like that. Okay, so 10.1.2 now says determine the probability that at least two of the events will take place. At least. Again, at least two of the events. This means it can be two or more than two, right? So it can be two or three events. Now let's start by indicating where we have at least two, right? So where we have two, meant to say, let's start by indicating where we have only two events occurring. So this here would represent the intersection between A and B. So that means only event A and B would occur. The probability of A and B only occurring is 0.1. The probability of only B and C occurring is 0.2. And the probability of only A and C occurring is 0.15. But then remember, they said at least 2. So that means it can be 2 or more, which means that we would have to also include the intersection of the 3 events. So we also have to include the X value here. Remember, we just calculated the X value in the previous question, 0.16. So in determining that, that means now we are going to say the probability that at least 2, so 10.1.2, probability of at least 2 events is equals to 0.1 plus 0.15 plus 0.2 and also the 0.16, right? And then at this point, you will have your probability as 0.61 rounded off to 2 decimal places. Right, okay. Now 10.1.3 is asking now for 5 marks. Are events B and C independent? Justify your answer. Are they independent? So we have to find that out. Now we know the formula for independent events goes as P, A, and B. So they're asking about B and C. So let's edit that one to B and C. Probability of B and C would have to be equal to the probability of B multiplied by the probability of C, right? So that means let's first check what is the probability of B and C. It would involve us having to add these ones here, right? The probability of B and C. Note that it's not B and C only. So it has to include all of that. So, okay, the probability of B and C is, let's note it here. B and C will be 0.16 plus 0.2, right? Which is, if you add them together, that's 0.36. Okay, then let's look for the probability of B. Not sure if you can see this color there. Let me change it. Then probability of B is all of B here, so that means we add this, this, that, and this. So our probability of B, we are going to find 0.643. We add that together. And then let's look for the probability of A. I mean, probability of C. So it's this, 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 and that. Okay, then when we add them together, probability of C gives us 0.56. Now, obviously, what we must prove here is that if we multiply the 2 here, it must give us the 0.36. So let's go. Say therefore probability of B times probability of C. Let's prove. If we say 0.643 and then we multiply that with 0.56, let's punch it on our umshinwe ibalo, and then we find that it is exactly 0.36. So that means since this here, the multiplication of this is equal to the intersection, we'll say therefore B and C are independent events. Independent events. And then that's how you were supposed to calculate that one. So I hope it makes sense. So for 5 marks, that's the trouble that you had to go through. Okay. Now let's go to 10.2. As we already know, that's our counting principles. A 4-digit code is required to open a combination lock. The code must be even numbered. So always pay attention to the restrictions. Even numbered and may not contain the digits 0 or 2. So may not contain the digits 0 or 2. So we know that we have 10 digits starting from 0 to 9. So if we are excluding 0 and 1, that means we are only left with 8 digits, starting from 2 all the way to 9. So the digits may not be repeated. Another important statement. So digits may not be repeated. How many possible 4-digit combinations are there to open the lock? So, okay, 10.2.1, we have our 4-digit code, 1, 2, 3, 4. But then we have a restriction here. They say this must be even numbered. Now, knowing our numbers, we know that in order for a number to be an even number, right, it needs to end with at least a 0, a 2. So basically, it needs to either end with a 0 or an even number. So in our case, it's 0, 2, 4, 6, 8. But then remember, the restriction is we may not include the digit 0 or 1. So here there is 0. Just going to scratch off the 0. So that means we are left with 1, 2, 3, 4. We have 4 options to fill in our last digit here. So we can either put a 2, a 4, a 6, or an 8. So we have 4 options. You understand that? So that is not to say that we're going to put 4 numbers there. We have 4 options to choose from. Remember, it's probability. We are looking for the chances, right? And then if we have filled in a number here, this leaves us with how many numbers? 7 numbers, right? So that means the other 7 numbers, we can randomly put them here. So how many options do you have to fill this block here? 7, right? Then if there's already a number here, how many options can you choose from to fill this block here? 6. If you already have put a number here, how many options can you choose from? You can choose from an option of 5 remaining numbers. And then obviously, to now get the number of possible ways in which you can form that code, or yes, is it a code? Yes. Then 7 times 6 times 5 times 4. Then you simply punch in your umshin weibalo. Then this gives you 840 possible 4-digit code, right? So, okay, that's all you needed to do for 10.2.1. So 3 marks. Okay, so just understanding what needed to be done and also the restriction. All right, then let's go to 10.2.2. 5 marks says calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000. So again, let's note, code must be greater than 5,000 and the third digit is 2. So they keep on putting more restrictions there. And the third digit must always be 2. So, okay, now, if they say this third digit must always be 2, note that this now affects our sample space in terms of making this an even number. So we said the numbers responsible for making the digit code an even number are 2, 4, 6, 8. But then now 2 is no longer part of the equation because remember we cannot repeat the digits. So if 2 is supposed to be on the second last digit, so that means that digit, right? Second last. So if it's supposed to be on the second last digit, that means we can no longer use it to determine whether the code becomes an even number. So that means we are only left with 3 options in terms of making this an even number. So I will go through each and every digit here, the case, right? So allow me to just break down this question for you. Okay, so now we have this case. Remember we said in order to make this an even number, we can either have 4, 6, or 8 being the last digits. So let's deal with each and every case. Let's say case number 1, we make 4, so 4 is the last digit. So 4 as the last digit, meaning that we can only fill this position in one way by putting a 4 here. So that means we can only fill this in one way by putting a 4. Remember here, we must always have a 2. So we can fill this position here only in one way by putting a 2, right? No any number must go in here. It must always be a 2. Now, Remember, we have how many numbers? When it comes to this one, we are trying to make this greater than 500. So that means the numbers that can go in here, the first digit, can either be a 5, 6, 7, 8, or 9. Right. So how many options do we have to choose from here? It's 5. So these are 5 digits. We can choose from any number here. Then this is 5. Now, if you have already put a number in here, and then there's a number here, there's a number here, that means you would have already used 3 numbers. And then from the 8 numbers that you have in total, excluding 0 and 1, that means you can have 5 options to choose from here to fill the second digit. Right. So you have already used 3 numbers, and then you are left with 5 numbers to fill in the second digit. Okay, now case 2. Case 2 is whereby you make 6 the last digit. So 6 is the last digit. So if you choose to put a 6 here, then that means you can fill this in only one way. And then the third digit, remember, it must also be filled in one way by putting a 2. Then, remember, in the first block here, you have 5, 6, 7, 8, 9 to choose from, right? But then if you have already put a 6 here, that has affected your sample space. So if the 6 is already here, that means we cannot count it as an option. So that's 1, 2, 3, 4. It leaves you with 4 numbers to choose from. You have 4 options. But then if you have a number here, a number here, and a number there, that means you have already used 3 digits out of the 8 digits that you have available. So that means you can only choose from 5 available digits after you have used the 3 digits, right? Now, case 3. Case 3 is where you make 8 the last digit. So 8 is the last digit. I'm supposed to say last here. Then, okay, if you choose to put an 8 here, that means you can only fill this position in one way by putting an 8. Remember here, that digit must always be a 2. We can fill this one in only one way. Now, here you can choose from 5, 6, 7, 8, 9. But then if you have already put an 8 here, that means it cannot go here as an option, leaving you with a sample space of only 4 digits to choose from. And that's 4. Now, if there's a number here, there's a number here, there's a number here, you've already used 3 digits, meaning you are only left with 5 digits to choose from to fill in your second digit, right? So these are all the possible ways in which you can create that code. So that means in order to now write it as a probability, because let's not forget, what are we trying to get here? The probability. So that means we would have to multiply this, find the answer to that. So let's have it here. We have 5 times 5 times 1 times 1 plus the 4 times 5 times 1 times 1, and then plus the 4 times 5 times 1 times 1. So obviously this here will have to give us 25, and then this here will have to give us 20, and then also this one here would have to give us 20. So if we say 20 plus 20, that's 40 plus 25, that's 65, right? So probability of that event occurring is 65 over the what? The sample space. Now the sample space will be represented by you having to just put the combinations the way just without any further restriction other than this one, right? So 10.2.1 would make our sample space. Remember, we had 840. So with only these restrictions that we are just bounded to. Then 65 over 840, when you punch that into your calculator, it simplifies to 13 over 168. So make sure that you punch in your calculator to see if it simplifies further. Then that becomes the probability of that event. So follow how we got to that one. So note that after here we add all these probabilities, and then that's how we got the 65. So, okay, that's how you were supposed to tackle this question, and then go about getting that 17 marks in total. So, with all that being said, guys, please smash that subscribe button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.